Welcome to the first video in the electricity unit. The first section we're going to look at is charge, current and voltage. And at the very start we're going to look at the basics of charge, what charge is, where do we find charge. So a lot of this you might have done before, maybe at GCSE, but it's just a bit of a recap to remind us the basics before we move on to the more difficult stuff. Okay, you can pause the video at any point or go back to the start if you need to, and if you try follow along and do the questions when required. Okay, so let's get started then. So fill in the blanks. Anything in red needs to be added to your sheets, and any labels I add to diagrams I'd like you to add as well. Okay, now this is our model of an atom, and our atom contains electrons, which are these around the outside, and they have negative charge. We have protons, which are in the nucleus, that's the middle bit, and they have a positive charge. And we also have neutrons, which have no charge, and they're also in the nucleus. So atoms with the same number of protons and electrons overall have a neutral charge. This is because both protons and electrons have the same magnitude of charge, they just have the opposite sign. If a neutral atom loses electrons, it becomes positively charged, and if a neutral atom gains electrons, it becomes negatively charged. Now, charged atoms are called ions. In each case, can you state whether these are positive, negative, or neutral? I'll give you a second to do that. Okay, so the first one has 4 negative charges and 1 positive charge, so it's overall negative. Second one's overall positive. Third is overall negative. And fourth is neutral because it has the same number of negative and positive charges. When objects that have charge are brought together, they experience electrostatic force. Now, the rule for electrostatic force is that like charges repel. That means if they have the same charge, they're going to push away from each other. And opposite charges attract. So if they have the opposite charge, they're going to come together. Let's look at these examples here. So in the first examples, we have 2 of the same charge. That means they're going to repel. The second example, we have opposite charges, they're going to attract. And the last example, we have like charges again, and they're going to repel. We measure charge in coulombs, and the amount of charge on an electron is negative 1.6 times 10 to the negative 19 C. Now, quite often we have to calculate the charge on multiple electrons. So if we calculate the charge on 5 electrons, we would do the total charge is equal to the number of electrons times the charge on each electron. So 5 times negative 1.6 times 10 to the negative 19 equals negative 8 times 10 to the negative 19 coulombs. Now, quite often in calculations during the electricity topic, we're not interested in whether it's a negative or positive charge, we're only interested in the magnitude. So when we get onto using equations that contain charge, we tend to ignore whether it's a negative or positive charge. So we've worked out the charge on 5 electrons. So let's think about how many electrons do you need to make up 1 coulomb of charge? Well, if we said before the total charge is equal to the number of electrons times the charge on each electron, we can flip that round. So that 1 coulomb, if we divide that by the charge on each electron, that will give us the number of electrons in 1 coulomb, and that is 6.25 times 10 to the 18 electrons. Now that's obviously a huge number of electrons, so the charge on each individual electron is very, very small, and it takes a huge number of electrons to make up even 1 coulomb of charge. Okay, so let's have a look at these questions. The first 2 we'll do together, and then the last 3 you can do yourself. The first question says, a neutral atom gains 3 electrons. What is its charge? So if it gains 3 electrons, that means it's becoming more negative. So to calculate this, we say the number of electrons times by the charge on each electron, 1.6 times 10 to the negative 19. And that's negative. And that's going to give us a total charge of negative 4.8 times 10 to the negative 19 coulombs. Now in the second question, we are not gaining electrons, we're losing electrons. So this time we're going to say we've got 2 electrons and we're going to times it by positive 1.6 times 10 to the negative 19. So our final answer works out as positive. And that's going to give us a value of 3.2 times 10 to the negative 19 coulombs. Okay, have a go at the last 3 yourself. Just be aware of this new notation here where we've got O2 minus. That means that it's got 2 extra electrons. So you can think of that as gaining 2 electrons. The next one is negative. It means it's got 1 extra electron. The final one's 2 positive, means it's missing. So you can think of that as losing 2 electrons. Okay, so when a charge moves, it's called current. And materials that allow current to flow easily through them are called conductors, and materials that do not allow a charge to flow through them or current to flow through them are called insulators. Okay, so what we're going to do on this page is we're going to do a little bit of research. Now it's not going to take very long, but it's an important thing to be able to do. It's part of our practical assessment at A-level, and we need to be able to reference our source material correctly. So in this case, we're looking at what material is a good conductor and what material is a good insulator. And we're looking for 2 of each. Now, all you have to do is you have to search Google and find a reasonable website that has information on conductors and insulators, and just write down 2 conductors and 2 insulators. And then you need to write down the website that you got your information from, along with the date that you accessed it. Okay, so pause the video now, go away and do that, and when you come back, I'll give you some examples that I found. Okay, so I'm going to assume that you have paused the video, you've done your research, and now you're back with 2 conductors and 2 insulators and a reference. I'm going to add to mine. I'm going to say that copper, this is what I found out, was copper was a good insulator, and iron, being another metal, was a good conductor. And insulators, I found that plastic was a good insulator, and also glass was a good insulator. Okay, now the website I got my information from was called www.goodinfo.com/conductors. Okay, now you've obviously going to have your own website there that you accessed, and then you have to write down the date you accessed it was, and just put down today's date. I'm just going to put down a random date, but you're going to put down the date you accessed it on. Okay, so current doesn't just flow through solids, it can also flow through liquids, and maybe you found that as part of your research. And in a solution or a liquid, a charge is carried by positive or negative ions. And in metals, the charge is carried by negative electrons. And metals are particularly good at conducting because they have a lot of free electrons. And we're going to come back to that later in the course. Okay, here's just a simple diagram of a circuit. So what we have is a battery. We have a wire with electrons represented in the wire. Obviously, there's a lot more electrons than what we've drawn here, but we're just showing what happens to electrons when we connect it up to the terminals of a battery. Now remember, electrons have a negative charge. So we've got a negative charge here. Now that means, remember, like charges repel and opposite charges attract. So our electrons are repelled from the negative end of the battery and move in this direction around the circuit as they're attracted towards the positive side of the battery. Okay, and that's the direction the electrons are going to flow around our circuit. If you can just add this diagram to your notes now. Current is measured in amperes, which we shorten to amps. It's defined in terms of the magnetic force between two current carrying conductors. Now don't worry, we'll come back to that later in the course. And current is the rate of flow of charge. Now this is important. I'd like you to memorize this because I'm going to test you on this in the next lesson. This is a definition you need to know. Now anytime you see rate in a definition, you know that means per time or per second. So the current is the same as saying it's the amount of charge passing per second, and this gives us our formula. Here we can see the current is the amount of charge passing per second. Now the amount of charge is given the symbol Q, so Q is the symbol for charge, and we measure that in coulombs. T is the time measured in seconds, and I is the current, obviously, measured in amps, which we give a capital A to. Okay, one way we can define an amp is it's the equivalent of 1 coulomb of charge passing a point within 1 second. Okay, so it's time to apply our knowledge. Now this question is very similar to one that comes up in exam questions. If you feel confident, then just pause the video and have a go yourself. Otherwise, stick with me and we'll go through it together. So the question's asking how many electrons must be passing a point in 5 seconds if the current is 2 amps. So it's given us the current, it's given us the time. So we're going to be using the formula I equals delta Q over delta T. So the current is the charge divided by time. Now we're going to rearrange this to find the total charge passing a point, because we need that before we can work out the number of electrons. So the charge delta Q is equal to IT. Now our current is 2 times our time, which is 5, and that's going to give us a total charge of 10 coulombs. Now if you look back in your notes, you might remember that we worked out how many electrons made up 1 coulomb of charge, so you can use the same method to find how many electrons make up 10 coulombs of charge. So we just do the total charge divided by the charge on each electron, and that's going to give us a value of 6.25 times 10 to the 19 electrons. Okay, so there's a few more questions here I'd like you to have a go at. I'd like to try these on your own. Just work through them. They start a bit more straightforward and they get harder as you go through. And we will go through these in class in the next lesson, so make sure you've had a go.